In this problem, I'm given a circuit with 3 resistors. Resistor R1 and R2 are in series together, but are also in parallel to resistor 3. So to solve this problem, I'm going to have to apply both my rules of resistors in series and my rules of resistors in parallel. The way they've put the variables on the left-hand side, the order in which they're supplied, allows me to work through the problem in a way that will use what I've already figured out to help solve for the next variable. So let's start with the first part where it asks me to find my total resistance. To do that, I'm going to start with finding my equivalent resistance for R1 and R2. And because they're in series, I'm going to use my series rules. So I can say that the total resistance of R12 equals the resistance at 1 plus the resistance at 2. So I can say that R12 equals 10 ohms plus 20 ohms. So my equivalent resistance, resistors 1 and 2, is equal to 30 ohms. But I'm not done yet because I need to find the resistance of the overall circuit. So now I'm going to apply my rules of resistors in parallel. So I know that the equivalent resistance, or now I'm going to say my total resistance, is equal to the resistance, 1 over the resistance at R12, plus 1 over the resistance at resistor 3. So I can substitute in my values and say that 1 over 30 plus 1 over 30 ohms is going to give me my total resistance. In this problem, my math is pretty easy because my common denominators are there. They're both equal to 30. So I end up with 1 over my total resistance equals 2 over 30. And I can reduce that fraction to say 1 over my total resistance equals 1 over 15. I'm not done yet. I have to get that total resistance in the top part of my fraction here. So I need to do the inverse of both my fractions, which will end up giving me that my total resistance is equal to 15 ohms. And I'm also going to go back up here and put that in my list of my givens so that I can use that information as I move forward through my other problems.